Below is a balanced chemical equation. So we have the reactants on the left, the products on the right. On the reactant side, we have CH4 plus 2O2 yields or undergoes the chemical process of CO2 plus 2H2O. So now we have to compare on both sides to make sure that we are balanced. So let's look at the carbon. So we have one carbon on the left. We have one carbon on the right. We now are going to look at the hydrogen. We have 4 hydrogen on the reactant side on the left. We have 4 hydrogen on the product side, because we do 2 times 2 gives us 4, and then we have a subscript 4. Let's take a look at the oxygen. We have 2 times 2 gives us 4 oxygen. Then on here, we have 2 oxygen here, and then we have 2 oxygen here. 2 plus 2 gives us 4. Again, we are not paying attention to the mass right here. Look out. At this point, there are equal numbers of carbon, hydrogen, and oxygen atoms on both the reactant and product sides of the equation. There are 4 atoms of hydrogen, 1 atom of carbon, and 4 atoms of oxygen on both sides of the equation. Now the equation is written in a way that obeys the law of conservation of mass, so it is balanced. Getting technical, chemical equations of automobiles. One way that you are protected in an automobile crash is from the inflating of airbags. Upon impact, the airbag inflates very quickly and provides a cushion for the passenger to prevent injuries. The following chemical equation represents the primary reaction that causes the airbag to inflate. So we have 2NaN3 yields 2Na plus 3N2. NaN3, or sodium azide, is a solid reactant in a chemical reaction and is stored in a very small space, such as the steering wheel of the car. When a crash occurs, the reaction begins. N2 is known as nitrogen gas, which takes up a large volume and inflates the airbag. It is important for scientists to understand the chemical equation of this reaction. They must know how much sodium azide is needed to produce a quantity of nitrogen gas that will inflate the airbag properly.